All right, hello everyone. Today we are going to talk about two more functions on our Micro 850 PLC motion control system. So today I wanted to talk about two function blocks, our MC home and our MC absolute. So in setting up for these, it's important that under our access configuration, if we go under homing, that we have this home input or this home switch input, and you don't really get the option for the channel, for this particular channel. It wants us to use the digital input 2 on our PLC rack. So for this particular configuration, setting that for an active level of high, meaning so that it'll look for when that signal goes high, that it'll recognize it is reaching the home input switch. So we want to be careful of that. I think it may have been in a previous PowerPoint slide. I had it set as the home marker input, and I saw that on a couple other PLC programs where students had that selected. So just make sure you're looking for this home switch input as part of your configuration. Okay, so once we have that set up and our other parameters set up like we discussed previously, I'm going to go ahead and turn this off. So now we can look here at our PLC function blocks. So for our MC home, I've got here is some of the inputs for that function block. We've got our stepper, or what I call stepper. It's whatever you've named the axis and that you have configured. And then we have for execute, I have mine set up as this particular variable that once that variable goes high, it'll execute that function block. And then we have here our position. So this is once it homes, once it finds its home position, it's going to rewrite whatever value is here in this, either under this particular variable, or you can directly type that in or type in a number for this variable, and it's going to put that position or rewrite the position of the axis with whatever number is in this input, okay, for this real input. And so it's going to rewrite that, and say you have a 10 in there and it finds its home, it's going to rewrite that position, that home position, with a 10. Or if you have a 20 or a 200 or a 0, it's going to rewrite that position with that value. This homing mode is, we've got 4 different, well, no, I think there's more than that, maybe 5 different. Let's go to the help menu. So if we hit F1 while we have that one highlighted, it'll go to our help menu, and it looks like 5 different modes in which that homing sequence can operate. The 2 that I think will be of most interest or help to you in this capstone project is this first one, the 0 mode. This is where it uses that home absolute, or that home switch that we have in digital input 2. And that's where it'll look for that switch in order to determine its home position. Or there's also this mode 4, a value of 4. And what it does is it just, whenever the homing mode is executed, wherever that axis is, it will consider that its home position, and it'll rewrite that position value that we have tied to our function block as the positional value of the axis. So if you were, depending on how you have that set up to home the axis, you could either use a 0 by looking for that digital input, or proc switch for the tray, or you could use it as a way to use that proc switch as a way to stop the tray. Like say you're doing a return velocity and you use that proc sensor as a way to stop the tray, and then you could use this mode 4 as a way to execute the homing position with the tray in that position to rehome um, the axis. Okay. Uh, so that's going to be important to have that homing sequence or something that works if you are looking to do this absolute move as a way to move the axis back and forth. And this absolute move move absolute function block is nice in that you can tell the axis a particular position and then it'll move to that position. And it doesn't matter if it's positive or negative relative to where that axis is. It'll move to a target position from wherever it currently is at. Right. But in order for this to work, we have to have homed the axis beforehand. So it has to see that the homing sequence is run and that has been established. And then it'll allow you to use this move absolute function block. And we would need to home anytime that we power off and then back on the stepper drive. Once that, and that's from that MC power function block. Once that has been disabled and then re-enabled, you would need to home the position of the tray or that axis in order to be able to use this move absolute function block. So looking at this move absolute function block, it has a couple of different inputs. So we have our axis that we're using. So here I've got mine named as stepper. We have an execute bit, Boolean bit that is used to turn the system on or off. And then we have our position that we are moving to. So you can see here I have mine set up as a variable that I can rewrite in my ladder logic to move that position, adjust that position as I would like. And then I'm reusing these variables that I'd used in previous function blocks for both my velocity, acceleration, deceleration, and jerk. This direction is actually ignored. If you go into the help menu for this particular function block, it'll show that the direction input is ignored for this one, so you don't need to put anything in there, as well as the buffer mode. As outputs, again, axis, there's nothing really to do there. The one that I'm mostly looking at is this stepper absolute done, or what the done bit. And then I've tied that to an axis that lets me know that it was moving to that location, or I'm moving to the location, and then I'm looking for when it's done before I try to initiate any other commands that I would want to do when it's in that position. Okay, so let's just jump to the variables list. And I don't have my PLC hooked up, so I can't simulate this like I would like to. But just to show a couple of different things that we would need to have active as we are initiating the sequence for an absolute move. So again, here's my MC power. So I would want to have my forward and backward bits as on or active, right? High or true, whatever you want to call it. And then also my stepper mode would need to, or my drive would need to be enabled, which I have tied to this stepper on. And maybe it's more helpful if I expand this MC power out and just use these variables instead of the ones I've renamed. So we've got this enable positive, enable negative that we'd want to have both as high, and then we can go ahead and enable the MC power to enable that function block, okay, or activate it. And then moving down here to the MC home. So at this point, we would have a position tied in our home mode for this function block, and then by activating this bit to execute it would enable the home mode. And so if we're doing a position or a home mode of 0, what it's going to do is it's going to move just like we configured in our homing configuration for the axis. It'll move in a negative direction, and it'll move back. So it'll move backwards until it sees the home switch go high, right? And that would be that proc switch. So it'll see that home switch go high, and it'll continue to move past it just a little bit to wait for that switch to go low again, and then it moves, and then it'll advance in a positive direction and go past that switch, and then it should come back back to it, and then set whatever position we have set for that this position bit here. Okay, once we've initiated or set that homing sequence, then we can utilize this move absolute function block. And here in this move absolute function block, again, we would have this positional value set, or we're writing to that as part of our logic, depending on where we want to move that tray. Velocity, acceleration, deceleration, and jerk. We would want to have those predefined somewhere. Either, again, we can type those directly in as hard-coded values into that in for those inputs, or we can tie those into a variable that we're allowed to write to and adjust, or that is a common variable used by a lot of these function blocks. And then we can execute that, again, tying that to a different different bit that then we can toggle on and off. And it just looks for the rising edge. So as it sees the rising edge of that bit, it'll begin the execution of it. And even if that's still active by the time it finishes the execution of that move, it's not going to try to move again until that bit goes low and then goes back high again. Okay, so that was just a little bit about both our MC home function blocks and our MC move absolute function blocks. And what I really like about this project is there's a couple of different ways in which you can try to manage the motion of that axis. So this is just another tool set that you can use, or you can go about it in another fashion to make that work. But hopefully that is helpful and able to make use of that. Again, if you have any questions, feel free to email me, and I will be happy to answer them. All right, thanks, everyone.